Chapter 1: A Day Without GPS.
It happens in less than 1 minute. 14,000 aircraft lose their invisible rails in the sky. The entire planet suddenly forgets where it is.
No bombs, no hackers, just the sun reaching a little too far.
Chapter 2: 8 hours earlier. The warning almost nobody listened to.
At a quiet space weather center, a monitor turns blood red. A solar flare, followed by a massive coronal mass ejection, is racing toward Earth. Arrival window, sometime today. Impact, severe geomagnetic storm.
But severe is abstract. It's just another risk line on just another PDF. Airlines don't cancel flights. Cities don't pause rush hour.
The world keeps moving because GPS never fails. Until it does.
Chapter 3: 0 Hour. The ionosphere starts to boil.
High above Earth, GPS satellites orbit like a silent metronome, each one broadcasting timing signals measured in billionths of a second. Every phone, ship, drone, plane, listening.
Then the storm hits. Charged particles slam into the upper atmosphere. Radio waves bend, scatter, and vanish.
First, it looks like noise. GPS positions drift a few meters. Autopilots quietly correct.
Then it's tens of meters. Then hundreds. Then nothing.
Chapter 4: Over the North Atlantic. 14,000 metal tubes hanging in organized chaos.
A long-haul aircraft cruising at 11 kilometers up. The captain glances at the navigation display. The magenta line, the digital lifeline, flickers.
GPS primary lost. Then a second amber message. Then a third.
Across the flight deck, independent GPS receivers drop offline. The moving map freezes on every passenger screen. The jet's inertial reference systems keep the aircraft roughly on track, but no longer perfectly.
The crew has trained for this, just not at this scale, because this time, it's not their GPS.
It's everyone's.
Chapter 5: Global, Simultaneous, Unforgiving.
In Europe, a low-cost airline watches an entire fleet go yellow on its operations map. Position confidence degraded. Route predictions unreliable.
In the United States, air traffic controllers see separation tools begin to fail. Conflict alerts slow, then misfire, then go dark. Their screens still show blips, but the math behind them is suddenly blind.
Quiet whisper.
The order goes out sector by sector. Maintain heading. Await vectors. We are experiencing a GPS outage.
Chapter 6: At Sea. The horizon becomes very, very large.
A container ship in the crowded Singapore Strait watches its electronic chart shift sideways. The vessel icon jumps several ship lengths in a heartbeat. Alarm tones bleed into the bridge.
The GPS-based track line melts away. The captain orders dead reckoning. Paper charts hit the table for the first time in years.
Thousands of ships worldwide are suddenly unmoored in digital space. Their autopilots drop to manual. Their crews scramble to remember how to navigate with compass, radar, and bearing lines alone.
Some officers are old enough to remember sextants. Most are not. Tonight, YouTube tutorials are useless.
Chapter 7: On the Ground. The streets forget how to move.
The car thinks it's 3 lanes to the left, then 2 meters underground. Failsafe code kicks in.
Rideshare apps spin endlessly. Delivery services stall. Navigation apps show blue dots drifting like ghosts across the map. The geomagnetic storm tears open currents in the ionosphere. Signals from GPS satellites scatter, fade, and phase-slip. Receivers on the ground can't lock on long enough to make sense of anything.
Chapter 7: On the Ground. The streets forget how to move.
In San Francisco, a self-driving taxi glides towards an intersection. LiDAR and cameras see the world, but its high-definition map is tied to GPS.
The car thinks it's 3 lanes to the left, then 2 meters underground. Failsafe code kicks in.
Across the city, every autonomous vehicle hits the same line of code. Position uncertainty above threshold. Initiate safe stop.
Cars coast to the curb. Some just freeze in intersections. A quiet, rolling paralysis.
Rideshare apps spin endlessly. Delivery services stall. Navigation apps show blue dots drifting like ghosts across the map.
People suddenly realize they don't actually know how to reach home. Not without the little arrow, not without the voice telling them when to turn.
Chapter 8. Root cause. Not malicious, just indifferent.
The geomagnetic storm tears open currents in the ionosphere. Signals from GPS satellites scatter, fade, and phase slip. Receivers on the ground can't lock on long enough to make sense of anything.
This has happened before, in fragments. Shortwave radio blackouts, power grids collapsing in Quebec in 1989.
But there's a difference now. In the last few decades, we wired almost every critical system to a single invisible clock in the sky, and we never asked what would happen if that clock stopped.
Chapter 9. Breaking point. The first near misses.
Over the Pacific, 2 transoceanic flights converge toward a waypoint that no longer exists. GPS-based separation tools are gone. Controllers fall back to raw distance estimates and time.
Flights are pushed into wide holding patterns over empty ocean. Fuel calculations tighten. Crews debate diverting to alternate airports they haven't flown to in years.
In one cockpit, a first officer holds a paper plotting chart with shaking hands. It's not in the simulator. It's from an emergency binder.
They mark position by radio beacons, time, and heading, the way it was done half a century ago, the way almost nobody practices anymore.
Chapter 10. Cities choke, not from smoke, from uncertainty.
In New Delhi, traffic police are overwhelmed. Without navigation, thousands of drivers improvise their own shortcuts. Side streets jam into gridlock spirals.
Emergency services lose optimized routing. Ambulances crawl, trapped behind confused commuter lines. Dispatchers shout street names people have never heard before.
Logistics hubs grind down. Warehouse robots reliant on indoor positioning systems tied to GPS timing drift out of sync. Conveyor belts pause because the database no longer trusts where anything actually is.
Groceries, medicine, spare parts, all trapped one layer back in the chain. They still exist. They just can't move.
Chapter 11. The invisible failure. Timing.
Stock exchanges, telecom networks, and data centers don't care about latitude and longitude. They care about time, precise, nanosecond accurate time, often derived from GPS signals.
As the storm peaks, time sync packets arrive late or not at all. Trading systems lose lockstep. Some markets trigger automatic circuit breakers just to be safe.
Cell towers desynchronize, dropping calls and data. Some fall back to local oscillators and backup protocols. Others simply reboot.
Most people blame the network or the app. Very few realize it's the same problem as that frozen plane over the Atlantic. The same problem as that stranded cargo ship.
Chapter 12. 24 hours. Long enough to measure in billions.
Aviation authorities order every aircraft with degraded navigation to land as soon as practical. Thousands of flights divert. Tens of thousands of passengers sleep on airport floors.
Airlines bleed money on fuel, crews, compensation, and rerouting. Perishable cargo expires in the wrong continent. Slots and schedules take weeks to untangle.
Shipping insurers quietly recalculate risk. Ports process emergencies instead of schedules. One grounded megaship blocks 2 berths for an entire day.
Rideshare companies lose a full day of global revenue. Autonomous taxi fleets sit idle, reclassified from cutting edge to single point of failure. Investors start asking uncomfortable questions about redundancy.
Meanwhile, trading halts and dysynchronized systems wipe out a day of high-frequency profits. Some funds take 8-figure hits simply because their clocks were wrong. No cyberattack, just physics.
Chapter 14. Analog. A word that suddenly sounds comforting.
Old navigation textbooks sell out online. Sextant manufacturers get a week's worth of orders in one afternoon. Pilots dust off VOR navigation techniques and beg for more simulator time.
Governments hold emergency briefings. Space weather agencies that were starved of funding suddenly become the most important people in the room. Everyone nods solemnly about resilience and redundancy.
Engineers quietly admit something ugly. Real analog backups exist mostly on paper. In practice, almost nobody trains for losing GPS everywhere at once.
Chapter 15. The storm fades. The lesson doesn't.
After 24 hours, the ionosphere calms, GPS signals stabilize, receivers reacquire satellites one by one, like stars returning to a night sky.
Cockpits across the world chime back to life. GPS primary, a breath everyone was holding without realizing it, finally releases.
Cities, navigation apps quietly snap blue dots back onto real streets. Self-driving systems exit safe mode and request permission to rejoin traffic. Servers resynchronize their clocks like nothing ever happened.
Most people remember it as that weird day the maps broke. A glitch. A meme.
Chapter 16. Final twist. This was the easy version.
The storm that hit was severe, but survivable. Short enough that fuel reserves held, backup systems coped, and power grids mostly stayed online. It was, in a way, a free preview.
Because physics allows for worse, Carrington-level worse, storms that could last days, not hours, and hit with far more energy.
Now, imagine the same GPS blackout, but stretched across an entire week, with parts of the power grid gone at the same time.
No quick reset, no simple, remember that weird day? Just a slow unraveling of systems built on the assumption that space weather is background noise.
Our navigation isn't just in satellites, it's in habits, training, and design choices. We chose efficiency over redundancy.
We outsourced our sense of direction to the sky, and the sky doesn't promise to stay quiet.
Chapter 17. So here's the question. What if this wasn't a thought experiment?
If GPS vanished for just one day, who around you could still get home with no phone, no map, no grid of blue lines? Which systems in your city could still move, trade, and rescue without a satellite ticking in the background? And which ones would freeze the moment that invisible clock went dark?
Because the sun will flare again, the ionosphere will boil again, and somewhere, someday, the signal will drop.
The only real what if that matters is whether we'll be ready before the next wave hits.
If you're enjoying this episode, don't forget to like and share it with someone who'd love this conversation. Drop a comment below. I'd love to hear your thoughts and see this discussion grow. And make sure to subscribe to the channel so you never miss a new episode. Your support helps the channel grow and keeps these conversations alive. Let's build this together.